Welcome to the presentation for the assignment 2, Social Data Mining Techniques. This assignment is for real-time data collection project. About the project, the requirements are to build a web application that allows real-time acquisition of feeds. Here I have chosen Twitter, and store collected data into a remote data source like MS or MongoDB. To explore the walkthrough, please follow the link here, which will be provided in the presentation document. The technologies used are Python. One of the reasons that Python was chosen because of the code readability and range of libraries available to make a web app. For both backend development and fetching the tweets from Twitter account into cloud database and deploying web app with connection, Python was one of the two languages used. Others were HTML and CSS. So basically HTML is used to create web pages and web applications, and CSS is one of these better versions of HTML coded alongside HTML to provide beautiful edits to the web design and the web app that we'll be providing. Flask was one of the libraries, one of the micro web framework alongside Python. It was used to build web application by providing various inbuilt tools and libraries in it, and it makes things much easier. This Flask is one of the frameworks alongside Django that many of might have heard. And the cloud database that I have used is the MongoDB, which provides cluster on AWS for fee subscription to make schema-less non-relational database. So basically it is easy to use in JSON format data and to store it in MongoDB. And further, these all coding and the environment that was used was Visual Studio Code and Jupyter Notebooks. So this is the basic data model wherein the JSON file that will be captured, the tweet data, has these objects in it, which is unique ID, which is created by MongoDB database system itself. ID string consists of the ID string that Twitter itself provides into the tweets. Date, data, timestamp, and language. Created at tells the date and time at what time this tweet was posted, and text will be the entire data body, which consists of the tweet itself, and the source would be the link to the tweet. So filtering out these all objects, the two main things that are required for my project were text and created at. Establishing a Twitter development account. So initially we had to sign up and request for a developer account by answering few of the questions and providing the legitimate details and authentication provided. As per the protocols, we must have a Twitter developer account to access the APIs to communicate with our backend program and to access the tweets and related data. So creating a cluster in and a database in MongoDB was the first step, wherein I created a new cluster 0, which can be seen in the image, and I created a user with my name, and the authentication and all the firewall was created while making these settings. So these were the basic backend codes for creating the not the web app, but the initial fetching of the data from the Twitter account. So herein these are the codes, and to note, import tweeby is one of the package which is very convenient to access a Twitter API with Python. So I have provided the references in the end of the presentation, which tells how tweeby is beneficial in this particular case. I'll be walking through further ahead the entire process on how tweets were fetched and how a web app was created. Once this previous code is up and running, we can see in our cloud database MongoDB that these are the files. We can see total 255 tweets were fetched, and this is one of the tweet data. It is in format of JSON file key values, and these are the all the objects that were fetched. And I so since early in data model I already discussed that I only wanted data that and text, so I fetched them further ahead. So also my database name was Twitter feeds, and VP search was the collection part wherein all these files were filtered and fetched. These were the Visual Studio codes, wherein web app.py was my main Python code file, and here I have provided used the Flask libraries framework, and here I also connected the MongoDB string, but here I also created a new authentication for connecting to the database, which was test123 was its password. So just to not to create a mess, I created a newer connection string. But the database Twitter feeds with Twitter underscore feeds remains the same, and the collection field Twitter underscore search remains the same because we need to fetch data from there. This right hand side was one of the snippet for the layout, how I am going to provide the layout for the web app, and these were the HTML and main CSS files to create that web app. Wherein in HTML show.html file I provided the filters for the text and the captured date and time, so only those two things will be shown into the web app. So these were the references. Now I'll move forward to the walkthrough to the how the things were done. Hi, this is the second assignment for social data mining techniques. So I'll be quickly going through the codes and files that have been used to make this project. So this is the backend code wherein I fetch the data from my specific account, Twitter account, with the specific hashtag words involved in the tweets. Here I have used Tweepy, library, JSON by Mongo, and Mongo client has been imported to connect with my MongoDB cloud database. So this is the link, and these are the access keys for my Twitter from my Twitter developer account. So this is the class that we created for stream listener, and reader is in the end. So in the listener part, we have created different functions and methods to access the data, and for the specific data that we require from MongoDB, here is the database that we have chosen. The Mongo host is being called, which is the link, and database client. This is the database name that I have set in my MongoDB application cloud database. So I'll show it that just in a moment. And here I have specified that the data is in form of JSON, and JSON format will be created during the when the code will be run. And here the collection area where the entire JSON data and the tweets will be captured is Twitter search, which will be in MongoDB. So here I will run it once. So you can see tweets are starting to connect. These are limited to 50 or 100, which will automatically stop the loop. And when we see the clusters, cluster 0, and the collections, so this is a test one test collection field. This is the one that we are using right now. So you can see the JSON files for particular tweets which are being loaded here. ID, this is auto-generated one. These are the Twitter IDs. This is the text that we require, what we are looking for in the front end part. And now when I head into my front end web application, here I have used Flask to create the web app, and here is the secret key, access secret key that has been provided for the configuration of the app. And here I have provided the source for the tweets that are to be shown into the web app that is created using the HTML part. And here again the same string has been provided, but I have created a new cluster with test name, and this is the password. And here I am returning the feeds database, and the Twitter search is the collection part which will be captured. Since we are returning this item details into HTML sheet, the HTML code, it is lined up here, and we have created a for loop for the things that we only require from entire tweets that are being captured. So here I have specified that the text part and the created ad. These are two things that I want in my web app. This is the layout template that I have created, and now when I run my web app.py Python file, here we can see all the tweets, and these tweets are specifically to my account which I created, the developer account. This is a very basic web app that I created with the help of Python and MongoDB and Flask. If we see the Twitter account, since I have provided the hashtag fields, specific hashtag fields here, so it'll only capture those tweets which have these hashtags in them, like MUFC, machine learning, and delta wave, which is very precise. And so yes, this is pretty much it. Thank you